pretty much the same. So if you, again, if you don't want the hard copy of the textbook, you can, I'm not sharing my screen, am I? I'm sorry. There we go. So chapter 2 is graphical descriptions of data. So that's going to kind of explain how graphs work. There's a ton of different kinds of graphs. You don't have to memorize all the different names of all these weird graphs, but there are a few main graphs that you need to understand. Definitely the frequency distributions, there's a whole section on that. And then the histograms, okay? Those are the important graphs that you're gonna wanna know. In the rest of chapter 2, so you wanna be able to kind of understand also how to read these graphs. And then in 2.3, you wanna be able to analyze the graphs, okay? So 2.1 is frequency distributions. They give us a graphical picture of kind of where all our data can be found, in what categories. And then the way we use these later is that they tell us about the probability of, if we take one sample from the population, what do we think the value of that sample is going to be? And we think that's probably most likely going to be, you know, wherever our frequency distribution is large, okay? So these frequency distributions are really important because they kind of show us our probability distributions later on, all right? And then in 2.3, you're going to learn about interpreting data. And you really just want to know that when you are creating a graph or when you are reading someone else's graph, even if the information in that graph is 100% true and accurate, it doesn't mean that that graph can't be misleading, okay? The way people decide to present their data can influence how people interpret it. So here I say that data is more than a mean. And what I mean by that is people will say, you know, the average person, well, not very many people are actually the average person, right? Very different. So to try to, as an averages can be misleading, okay? So that's what I want you guys to take home from chapter 2 when you go through these PowerPoints and videos, right? And then when you get to chapter 3, we are going to learn about, what's the name of chapter 3? Numerical descriptions of data. So again, things are more than just the mean. There's a lot of different ways to kind of describe where the center of our data is, mean, median, and mode. And often in statistics, we use median and not mean, and that's because our data is not symmetrical, okay? Then in, I think it's 3.2, yeah, 3.2 is measures of dispersion. And so that tells us dispersion means like how spread out is our data, okay? And that's where you're going to get standard deviations, variation, and quantities like that, okay? There you're gonna have to start using formulas, and that's where you're gonna wanna decide, hey, do I wanna learn how to do this in Excel? Do I wanna use my calculator to do this? Or do I wanna just, you know, do it by hand using the formulas, okay? And when we have a small amount of data, doing it by hand using the formulas is not that bad. Okay. Another take home from chapter 3 is that you are going to want to understand the difference between a sample and a population and understand why we have different calculations for those. Okay, we can talk about that more next week after you guys have seen the videos. But just keep in mind, anytime you're doing a calculation, you know, am I calculating this for an entire population, or am I calculating this for just a sample of a population, okay? All right, so I've got a question. Is it mandatory to learn the formulas or can we rely on the calculator? The formulas are not that complicated to remember. I want to say yes. Sorry, my dogs are pushing in my room. I want to say yes, you need to learn the formulas because the formulas are going to, like, understanding the formula helps you understand where this information is coming from, and it tells you the meaning of that information. But when you get to the test, if you know how to do it in your calculator without the formula and you can get the answer, you know, you don't have to have the formula memorized. Okay. But do make yourself familiar with the formula, if only you understand what that number is telling you. Okay. So let me, I have a couple pictures I want to show you guys to kind of illustrate what I am talking about. So when I am talking about how the mean is sometimes misleading or data is sometimes misleading, one place that that often occurs is when we have what we call skewed data. Okay, so see how this data here, this is the distribution of household income in 2014. So this is a frequency distribution. And the height of these bars tells you how is the count of households, the number of households that make these amounts of money, okay? There's only a very small amount of households that make, I guess this is about $500,000, $1 million. There's a lot of households that make, what's in here, this must be like $30,000 a year, okay? So this is gonna be our mode, because the most number of households make $30,000 a year, okay? But our median is gonna be where half our data is. So this 50th means that 50% of our data is below and 50% is above. So our median is at $53,000 a year, okay? That's the median household income. But then because this data is skewed, the mean or the average is actually somewhere around $80,000, okay? So somebody might tell you that the average household income in the United States is $80,000. That's doing pretty good. But when you look at this chart, you're kind of like, yeah, but the majority of people, more than half the people, are making less than $80,000. Okay. Exactly half the people make $53,000. Okay. So that's how the mean, which is at 80, can be misleading, and the median is maybe a better, better piece of data to share with people. Okay. And even then, if the median is $53,000, you see that there's still a large number of people that are making less than $12,000 a year to people making $150,000 a year. There's half as many people making $150,000 a year as there are making $12,000 a year. Okay. So that's kind of how we interpret the data like this. Just the mean is not enough information. Sometimes we need to know the mean and the median, and then we also like to know how spread out our data is, and that's going to be standard deviation, or our variance is going to tell us how spread out our data really is. Okay. And all those numbers together can give you a more complete picture of what your population actually looks like. Okay. So again, this is a frequency distribution for household income in 2014. And then let me show you another way that we sometimes look at this kind of information. these up top are 3 different frequency distributions, okay? This distribution is uniform, okay? I'm trying to think of something that we could say this represents that would be uniform. I don't know, I can't think of an example of uniform, but this frequency distribution is uniform. So even at the edges, there's the same number of people at 4 as there is at 16 as there is at 28, okay? So just knowing that the distribution is uniform and that the average is 16 tells us a lot about this population, okay? Compared to this distribution here, the average is still 16, but it peaks at 16 and then it gets a lot smaller at the ends. So knowing that this is a symmetric and it's peaked, or we would probably call this a normal distribution, tells us a lot about how this pink distribution is different than this purple one, even though the means are the same. Okay. And then this third one is skewed to the left. And you might initially look at this and be like, but there's more stuff on the right. We call it skewed to the left because the mean is going to be skewed to the left of the median, okay? If we go back to our other distribution that kind of looked like this guy is skewed to the right because our mean is to the right of our median. Or what it's saying is the outliers are to the right, and these outliers, the people that make $1 billion a year, are skewing our mean to the right, even though there's just a few people here. Because they make so much more money, it pulls the average income to the right. All right, so something like this is skewed to the right, and this picture is skewed to the left. So these are how we look at frequency distributions and how their shapes actually tell us a lot more information than just knowing the mean of these populations. Okay. Those are the frequency distributions, and then these guys below them are what we call their box plots. Box plots also give us a lot of information, but you have to learn to read them. So what a box plot is this line in the center is the 50th percentile, also known as the median. So half the stuff is, in this blue one, half the stuff is below 15 and half the samples are above 15, okay? And then where the box is between 25% of the things and 75% of the things, okay? So the middle 50% is in this box, okay? And then the top 25 is here, we call that a whisker, and the bottom 25 is here, the other whisker. So this can kind of tell you, since this guy's uniform, this whisker, this box, and this box are all the same size, okay? Because the first 25%, 25 to 50, 50 to 75, and 75 to 100% of the population all are spread over the same distance of spread. Okay. This symmetric one, this peaked symmetric in pink, shows us that most of the population kind of groups towards the center. All right, and so for that reason, the spread of values here between what is this? 0 and 28. Okay, so the spread between 0 and 28 is between here and here, but 50% of our data points, 50% of our samples are all inside this pink box. 50% of our data is between 12 and 17. All right, so that's what that's showing you, is this is 50% of our data. All right, and the other 50% of our data is spread way in these two areas. So there's as much stuff here in this big space here as there is in this little space here. So that's what a box plot is showing us for this distribution. And then for this third one, the skewed to the left, you can see it's got this left tail, and that's what it's showing here. Our median is way up here at 20. So half the stuff is above 20, half the stuff is below 20. But this is a big spread of data and there's not that much data here. Okay. So these are our box plots and they correspond to these frequency distributions. And it's a weird picture, but they actually, each box plot, it's not common that we see, in scientific papers, you see box plots a lot. We don't see them a lot when you say get your statistics on Facebook or something. But once you can understand them, they actually give you a lot of information, okay? All right. Do you guys have any questions on that?